Whatever you want to wipe down my marker board for me. This one. Just clean it completely off. I want it white.
Oh, I don't know if I can do it.
Yeah.
Can I sit there?
Yes. It was cheaper.
That's cute.
Yeah.
Sorry, oh, and this one's you. This one's probably you. Oh, shit. He said he has that all white, so it makes me white.
Thanks for not research that. What? What's that? You want to do the orange juice?
What's it good look like?
No, there's me. Yeah. I'll have 2 videos going. I have 2 different things going today. So let's see how we can.
Okay. So, see who is here. Who is that? Bretta. I'm sure she'll be here. She's probably in. Who else we missing over there? Lucy's gone. And is it Rachel? Yeah, where's Rachel after that?
No, she was here this morning.
I don't know. They're probably so that's what they all need. All right. Okay. Let's see. What do they like home? We'll check on. She had done some, so she won't be back. For tennis, well, a lot of tennis tonight. Right. So she's okay. All right. Today we're going to do a couple notes on linear equations today. I want to review how to find intersections today. You know, those common points where two graphs share. But we have to get there first. So remember, we're on section 3.6, which is linear equations. Actually, is it 3.4? I think it's 3.4. 3.4. What am I saying? 3.4, not 3.6. 3.4. 3.4. We're talking about linear equations. And the big deal with these linear equations is just knowing, the different forms, which we've talked about, the 3 days last week. So hopefully you're very, very comfortable with the different forms and, their purposes. So the first one was point slope. That's the one that I like the most, point slope form. If you don't remember that one, that was the one where if you have a graph, you can go right to an equation. So, all right, so we can go right to the equation, which that equation is this. Okay, so that's the equation. Again, how this works, that slope, this is the coordinate that's on the graph. These are just variables. They'll stay variables unless you're going to try to predict something, so you'll plug in an X or Y number. Okay, the second form. The second form which we discussed last week was, I should write down the name. It's called slope-intercept form. This form, if you don't remember what we talked about last week, this form is really good. If I give you the equation, you can go and graph it really fast. So this is y equals mx plus b. Okay, so that's really easy to graph that. And then the new forms that we definitely talked about on Friday, the sub introduced them Thursday. I was gone Thursday. So the sub introduced standard form, which was our topic of choice for Friday. Standard form is really good for story problems. We can find intersections of lines if you have it in standard form, and this is the form. AX plus BY equals C. The A, B, and C are just numbers. They're actual digits. They're whole numbers, not fractions or decimals. I'm going to give you an example today where we have to change that. If they give you fractions in there. And then the last form we talked about was general. And that's the one we probably won't see a lot of general form until later next semester when we start factoring. That'll be a big part. I don't think they'll introduce factoring in chapter 4. It might be in the later chapters. So we'll see that. And at some point, even if it's in the book or not, we will have to cover it because you definitely need it. And that form really looks like standard form. The only difference is they have 0 on the one side. So basically what it is, they just took this constant number and just moved it over. So they either added or subtracted it. I don't know if that's a plus or minus, it depends on what your number is. But they have 0 on the right side. And then from there you can solve. Those are the different forms. Was there any questions on those types? Okay, I believe the video for Friday's section, I think it should be online today. I think it's actually I think it's uploaded already. I'll have to double check before I let you guys go today. So if you want to watch that, and maybe you're gone or you just didn't quite get it. All right, today, goal is to talk about intersections again one more time, how to do it by hand, how to do it with a graph. Then we have 2 special cases today. We have 2 special cases, and that's where I want to end with today. Make sense? So we're going to go through at least a couple examples of finding intersections, graphing and normal, and then we'll end with 2 special cases, and that'll be it for today. No homework, we'll just do notes today. Okay? All right, so let's start. I'll put the problem over here. We'll start with kind of an intersection problem. So we'll start with general form, or standard form. So let's say we have, somebody give me 2 numbers, please. 2 and 7. All right, so 2x plus 7y. Let's say that this is 18, right? And we'll go with x plus 3y, and this equals, let's say this equals 8. Okay? All right, so let's say that these are my equations, right? There are 2 different lines, if you don't know. This is its own line, this is another line. And what we're looking for is, like, if this is a story problem, let's say, we were making up problems last week that you went to a department store like Target, you bought 2 t-shirts, you bought 7 shorts, and you paid $18. So they're super cheap kind of thing. Another person went in the store, bought 1 t-shirt, 3 shorts, and paid $8. So you can definitely tell those, whatever these items are, they're cheap. The X and Y represents cost of these items. So these numbers are how many you bought. There's 1X, 3 Ys. and these are the prices, and this is your total if you spend. The thing is, we're trying to find the prices, so we don't know. We just know what the register told us the price was. All right. So to do this, the first step, make sure they're in standard form. Are these problems written in standard? Yes. AX plus BY equals C, and this is their constant. They're all nice whole numbers, agreed? They're not any fractions. We'll deal with that for a minute. That'll be maybe my second example. All right, so once we're at this point, what I'd like to do is draw a line. So we're stacking them on top of each other. The x's are stacked, the y numbers are stacked, the constants are stacked in the back. We have to pick one of the variables, one of the letters, x or y. Pick one that looks easy to work with. X's. Okay, they're easy numbers, right? The x's are 2's and 1's. Those are easy numbers to work with. 3's and 7, not so much. They're kind of ugly. What I want to make sure is, now that you've picked your variables, so we're going to pick the x's in this case. So let me highlight them. Okay, my goal is to make those two numbers the exact same number. That way, what we're doing is we're going to eliminate the x's. If we can make them so that they look the exact same x, then really the only differences between these would be the y numbers, like the y variables, and then the constants in the back, and then we can solve from there. Okay, so what's a common number between 2 and 1? 2. You could go to 4s, you can make these both 4s, you can make them both 6s. Basically any even number, because 1 can go in anything. So what we're going to do is we're going to multiply the two rows here, these are rows, we're going to multiply the rows by different numbers. Okay, so the top row, I'm going to multiply that by a 1, and the bottom row, I'm going to multiply by a 2. That way, the x's will turn out to be the exact same number. Basically what you do is you just multiply them together. That's how it kind of works. Okay, so the top row, if I took everything times 1, you get 2x plus 7y. 7y equals 18. And then on the bottom row, I multiply everything by 2, because I'm going to go double as much. So I'm going to buy twice as many items, and I'll spend twice as much money. That's just kind of how it works. Hopefully there's no weird deals where if you buy more, you get cheaper. So 2x plus 6y equals 16. Okay. Questions, comments about how I just did that? Now, why I did that is so that the x variables make no difference. We've basically made them the same, so really the only difference in price comes from how many shorts you bought, the y's. That's the idea. Okay, then what you do is once you have these numbers looking exactly the same, you always subtract straight down. So we always subtract. So we're going to subtract these straight down. This is how it works. We're finding the difference in prices. Okay, so when we subtract, the two x's basically go away, make 0. 7 minus 6 is 1, right? All right, so that's 1. You don't need to put the 1 in front. It's a y, 1y. And 18 minus 16, 2. That's the price. The y's are $2 a piece. Spent $2 on every pair of shorts. Okay, that's what we figured out. Now, if there was a number out front, let's say this was like a 3y here when you subtracted, then you divide by 3, and that'll be whatever your decimal is. Okay, but it turned out to be a nice whole number. Now, what we're going to do with that 2, once we have it, we plug it back in. You can pick any of the equations, any of the person's purchases, and you're going to plug it back in, and what letter are we plugging the 2 into? Y. So we're going to go, let's go to the bottom row, this bottom equation. X plus 3y equals 8. All we're going to do is we're going to take out the y and plug in the 2 that we just found. And then we can solve for x using common sense. So this multiplies to be 6. And I think you can figure out what your x has to be. X has to be $2. So the shirts are $2, and the shorts are $2. So each one's 2. And again, if you plug those 2's in to both equations, it does work. That makes 4. This makes 14 if I plug the 2's in. So 4 plus 14, yeah, that's 18. And then plug in a 2 and a 2, that's 2 plus 6, and yeah, that makes 8. So that's how it works. So those are, what this is, that's your common prices for both equations so that they work. If we were to graph these lines by hand, this is where they would cross. X coordinate of 2, y coordinate of 2. That's the idea. We'll go to graphing here a little bit, but I want to make sure that we understand that. Okay, questions, comments, concerns on what I just did there? Okay, that's the goal today, what you're looking at right there. I want to make sure that we practice a couple of these today to make sure that you personally can do this. So you've probably seen this. I know, like I asked last week, how many people have seen this, and some of the people that have taken Algebra 1 in high school have definitely done this before, or at least seen it, at least once or twice. But maybe those people that took Algebra 1 in junior high probably haven't. So we'll just make sure that we review that. Okay. And again, what this is called solving a system of equations. It's a system of equations. It's a comparison of two equations stacked on top of each other. We're basically trying to solve. That's kind of the goal of the system. And the method we're using is called the elimination method. Or if you look at like an Algebra 2 or pre-calc textbook, sometimes they call it the linear combination method. Elimination makes sense to me. You know, you're eliminating one of the letters. Linear combinations are when you did this. When you multiplied a row by like a constant, like I multiplied this whole row by 2, like I bought twice as many objects, the price changes by the same constant. That's a linear combination. That's why I understand why they kind of call them the two different names. But again, the goal is to solve, find a common answer for both equations. Okay, let's do another one so that we get some more practice. Let's do one where we have a fraction in it. Something where the equations don't look like standard form right away. So something like this. Y equals half x plus 4. And let's see. Let's go with 3x plus 2y equals let's go with make sure that this actually works out to be a nice one. I think this should work. It didn't come out right in my head. Let's see. No, wait, no. No. Mm. 32. 38, 32, let's see. Yeah, that's right. Yeah, let's do that. Okay. All right. Okay, do we agree that the bottom row looks like standard form? Okay, that one's good. We want to leave that one alone. Okay, we might mess with it later, but let's leave that alone. Hopefully this works out. I did my math right in my head. All right, so there's that equation. We're going to leave that one alone. The top row, that's the complete hot mass. So we need to change that. That form is one of these others. Which form is it? Slope-intercept. We don't want that form. Preferably, we don't want that. There is a way to do this problem with that form. I don't like it. We're going to avoid it. Okay? All right. So, to do this problem, I want to change this equation. That's what I want to do. I want to change the equation. So to do that, here's what we're going to do. The first step, obviously, if we're trying to go to standard form, we don't want the fraction. You can't have fractions, right? Standard form can only be whole numbers and positive negatives. That's the idea. So what I'm going to do first is, this is the shortcut. What number is on the denominator of that fraction? 2. You multiply everything by 2 on that equation. If I multiply everything by 2, what will happen here is that it will cancel the fraction out. That's called a linear combination. I can multiply the entire row by 2, about twice as many objects. So what this turns out to be, if I multiply this by 2, it turns out to be a 2y equals, when I multiply this by 2, the 2 goes to the top, so that's 2 times 1, which is 2, and I divide by 2. What's 2 divided by 2? 1. What happens here? These basically cancel out. That's the like the rule of thumb, so that's the 1x. That's kind of how it works. But again, you multiply the 2 to the top, you can actually divide it. Then plus 2 times 4, that's an 8. Okay, does everyone see how I got rid of the fraction? Multiplied by whatever the denominator was. So now I'm here. This is my equation now. Does that look like it's in the standard form, though?
No.
No. So what I need to do is I need to change it. I need to move it around. I need to get it to look like this. So the x is out front, the y is behind it, equal sign, and then the constant. So on that problem, what is the only thing I need to move to make it look like this? Yeah, I need to move the x. If I can move the x to the other side, I can move this x over, it'll look like standard form. You'll have the x and y on this side, equal sign, and then the 8. But what happens when I move it? It becomes a negative. So really what that problem is this. It's negative 1x plus the 2y. The 2y was positive. And then I have the 8 on the other side. That's how you do that. What we're doing is we can change any of these equations, any of these forms. You can change them into the others. You just do basic algebra. So like on that case, I knew how to multiply by 2 to get rid of the fraction because I didn't need fractions. And then all I had to do is move stuff across equal signs. That's where it becomes positive and negative. That's basically the majority of what you have to do. Okay, so now that I'm here, now this problem is perfect. Now I can solve this problem by doing the same math we did earlier. So like when I look at this problem, okay, we have to pick a letter. So pick a variable, x or y. I'd probably pick y. The reason why? They're already the same. That's the brilliant thing. Like when you pick a variable, pick the easy one you want to work with to make them look the same. Well, in this case, they already are the same number. I don't even need to multiply by anything, which is awesome. They're already the exact same number. So all I need to do is subtract straight down. So when I subtract, what happens to a negative sign? Yeah, this makes a plus, because it's negative. V subtract, and then V subtract. That's how it works. I subtract every number straight down. So this becomes a positive, basically, because it was a negative. So what's 3 plus 1? 4x. Okay, that's good. 32 minus 8, what, 24? If I subtract it straight down. And then how do I solve for x? Divide by 4, yep. If I divide by 4, the 4 is canceled. So you use x, it's 1x, by the way. And then 24 divided by 4, that's 6. So that's my coordinate where that's the common answer. So the price, whatever x was, it was 6. Or that's how many of your items you're buying. I don't know what this x represents. So it's 6. Now, what am I going to do with the 6 now? Always plug it back in. So you're going to pick one of the equations, one of the originals, and plug the 6 back in. Here's what I recommend. Go with the easy one. Don't go with the weird one. Go with the easy one. You could even go up here. You could plug into this one. That's fine. This row. I typically try to go back to one of the originals. I don't want to go to something maybe I modified earlier. Because if I modify this, what if I got this equation wrong? So then I just got even more wrong from there. But I always try to go back to the original, take my 6, plug it in here. So I'm going to go to that equation. So I'm taking out, so I'm going to 3x plus 2y equals 32. And I'm going to plug in the 6 here. So plugging in the 6, this turns out to be 18. 3 times 6 is 18. Again, how I knew which letter to plug it into, it basically told me x is a 6, so that's where I'm plugging it in. Subtract the 18 across. So 32 minus 18 should be 14 if I subtract it over correctly. And then divide by the 2, and I get my y has to be a 7. So that should be the common number there. And if I want to double check, I could plug these in. I could plug in the numbers and see if it works. 6 and 7. If I go to let's go back to this equation. If I plug the 6 and 7 in here, plugging a 6 into this original 6 and cut in half, basically, that's 6 cut in half is 3. 3 plus 4 is 7. So yeah, that makes sense. Y is equal to 7. So, and if I plug the 6 and 7 in here, that's 18, that's a 14, and yes, those add to 32. Okay, any questions, comments about how I did that problem? And that was definitely that is definitely a different problem than we've had previously, like Friday. We've never seen a problem where we had fractions. I kind of want to show you that little rule, so if you ever have them, you can always get rid of them. Okay, my goal right now, I'm going to give you one problem, just one. Very easy. I'll already give it to you in standard form, so I want to see if you can solve it. That's what I want to make sure of. Okay? All right, so let's try one out here. You won't have to do any rearranging. It should be just solve it straight off the bat, and let's see if we can figure this out. All right. So here's my example. Let's go with 4x plus 5y equals. Let's go with how this kind of works. You can move around right now if you wish. Try to solve this problem out. I want to see kind of how you're doing it. So make sure you're showing me some work on your notes. And if you're not here Friday, we did have a homework due. That was page 193. Make sure if you weren't here, you can get that turned in. Anyone actually get a result from it? And solve it out? Okay, sure. What do you have?
I have white 1.
Okay. Anyone else have different numbers on that? Okay. Okay, those should be there. We're going to go through the results here in a second. So if you need a little more time, at least you know kind of what the results are. You know what you should be getting to. Then what we're going to do is we're going to practice graphing, so you can see that. Okay, so when you first start, what's the number in front of the X on the bottom row? The 1. Okay. So I always like to fill those in case you're kind of confused. It's not 0, it is a 1 there. There's always leaving a number 1. Okay, so now when we start this problem, you have to pick one of the variables, just one of the letters. So X or Y, you want to pick one that's easy to work with. So what letter up there, X or Y, is easiest to work with?
X.
Probably X, right? 1s and 4s are easier to work with than 3s and 5s. It really doesn't matter. You get to pick, but I agree the X's are definitely the easier variable to work with. Okay, so what we want to make sure right now is we want to turn these two X's into the same digit, the same number. So what was the common number that we picked? Like Trevor, when you did it, what was the common number you picked? Probably 4. Okay, turn them both into 4s. You could turn them into 8s, 12s. It really doesn't matter as long as you make them the same number. The top row is fine. I'm going to leave that one alone. That one already has a 4 sitting there, so I'm good with that. The bottom row, though, that's a 1. I need to multiply this whole row by 4. I'm going to buy 4 times as much products. So that's 4x, 12y, and then the 7 on the other side, if I take that times 4, what is that, 28? 4 times 7. Okay. Questions, comments, how I just did that? Multiplying the bottom row by 4. Okay, so now that we're here, what do we have to do there's like any negatives, basically they turn positive. That's how it would work. Okay, so we're going to subtract straight down. So this will make 0. This will make, what, a negative 7y? That's 5 minus 12, so that's negative 7. And when I go straight down here, that is a negative 7. 21 minus 28. And then the last step, divide by the negative 7, right? Divide by whatever number is else around, if there is one. So if I divide by negative 7, those will cancel out to make a 1y. And then negative 7 divided by negative 7, that is a 1. So that was your answer. Here, right? Y was the 1. That was the first letter we should have found. Then what do I have to do with the 1? Always plug it back in. Always plug it back into one of the easy equations. That's what I would make sure of. So plugging that back in, I'll probably go to the second row, this row, just because that's the easiest one to look at. I'll plug the 1 back into the 1. So 3 times 1. Is that, again, how I knew that the y was 1. So I plugged it back in. So 3 plus x equals 7. So the x had to be a 4 times x. 4 plus 3 is 7. Again, you could have plugged it back into any equation. It would have worked in the top row versus the bottom row. I think the bottom row is definitely easier. Okay. Questions, comments about how we did that? All right, perfect. Now, graphing this thing. Like, if you had to graph this, let's say you were like, you're trying to, like, let's say you're just not very good at this. You're like, you can follow it, yeah, it makes sense, but you're just not quite sure you did get it right. You could graph the 2 equations. And this, the graphing, and the reason I picked this problem to graph is that the graph is messy. That's why it's actually a preferred method for me to always do it that way, elimination. It's very clean, it's very cut. You know exactly where the answers are going to be. There's no problems with it. They turn out to be whole numbers. But when we graph, it can get messy because the lines aren't going to be exact. You're going to start with decimals, and you're going to work from there. So you have to be very, very comfortable with graphing decimals and fractions and whatnot. And that's where most people, like, they try to avoid graphing at like all costs because they don't want to look at it. The graph actually proves what your answer is, or it should get very, very close to proving it in case you were just off by an error from when you're doing your decimals. So I'm going to try to graph these. So I'm going to go to both equations. So the first graph I'm going to do is this one. That's the top row there. Okay? That's the top row. I'm going to graph this one first, and I'll put it in blue. And then the second equation we'll graph in red, and that'll be the x plus 3y equals 7. Just so we get some practice with graphing. Because I do want you to see this. And why is that? I prefer that. That's why I want you to know that. Alright, so when we do this, this is standard form. Now there is, I know like Algebra 1, they do teach you shortcuts for how to graph it very, very fast. I don't like it. What I prefer to take this, turn it into one of these forms. Now obviously it's already in standard, so we want to turn it to one of the others. Which form up here is the best for graphing? Yeah, this one, the second one, right? Slope intercept form. That is the graph. That is the equation you want to graph. It's easy to look at. Okay, now to get it to look like this, that means the y has to be by itself. So that y right here has to be by itself. So I'm going to have to move the 4x over, and I have to get rid of the 5 last. So let's move the 4x. What happens when I move the 4x over? It becomes a negative. So right now, this is negative 4x plus 21. Right? And then the last step, we have to get rid of the 5. Well, if I get rid of the 5, I have to divide by 5 to everything. That would get rid of the 5 here, so the 5s are gone. So it's y equals negative 4 over 5x plus 21 over 5. Now 21 over 5 is just above the number 4. 20 divided by 5 is 4. So it's just above it. It's like 4 point something. So this is my y-intercept on that problem. Remember, that's my b number. It's the constant in the back, so it's 4 point something. Blah, 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 blah. And then this is my slope. That's how the slope-intercept form works. The m is my slope, the b is my y-intercept. So 4 point something. So on the y-axis, 4 point something is like right here. It's 1, 2, 3, 4 point something. I don't care where. I'm just going to get kind of rough guesstimate where it's going to be. And then the slope is telling me to go down and over. It's negative, so it's kind of going somewhere like this, right? It's going negative. So it's going down 4, because again, this is rise over run. That's how I know the 4 is going down. And then the 5 is running that way. So down 4, 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. Down 4, 1, 2, 3, 4, over 5, 1, 2, 3, 4, 5. All right. And now I get a glimpse where that thing's going. Again, once you make your bunny leaf, then that's when you start counting. All right, so here's roughly where that graph is going. Again, it's not exact. Just give me a guesstimate. All right, there you go. So there's the first graph. Okay, now that we have that, now what we're going to do is we're going to graph the second one. I'll put that one in the red. So again, same rule here. I need to get that standard form into slope-intercept. So what do I need to move first? X. That's a 1x, right? I'm going to move the 1x across, so that becomes 3y equals a negative 1x plus 7. Because again, when we move it across, the equal sign equals negative. And then what do I have to get rid of? 3. So I have to divide the 3. So if I divide the 3 across, that's y equals negative 1/3 x, because I'm dividing it by 3, plus 7 over 3. And 7 over 3 is just above the number, is that above the number 2? 6 divided by 3 is 2. So 7 divided by 3 is just higher than 2. So it's 2 point something. And then the slope means to drop 1, run 3, 1, 2, 3, drop 1, run 3, 1, 2, 3, drop 1, run 3, 1, 2, 3, roughly. One, 2, 3. All right. So those are my dots, right? Going down 1 over 3, down 1 over 3, and graphing that. So here's my two equations. We can figure out where they roughly cross. They basically cross in that kind of area right there, which is not exact, right? So that's why the graph is a little bit sloppy, because we're using decimals. But roughly where that coordinate is, if you look, that it has the x coordinate of 4, the y coordinate of 1. 1, 2, 3, 4, up 1. Roughly. That's where it's roughly at. Okay. Makes sense why we choose the other way versus graphing. Now, some people like graphing. I don't. It's not exact. Sometimes, especially decimals, you get a little bit sloppy, you get a little bit off. You're not quite doing it perfectly. All right. Questions, comments about what we've done today? Okay. All we have. 2 things left, and they're just going on the graph. That's why I brought it up. Okay. All we're going to talk about today is 2 special cases of graphs. That's it. That's what we're going to stop with today. The special cases of graphs is not like where things are crossed. I don't care about that. It's the equation for a horizontal line and the equation for a vertical line. Every type of form up here, basically, that I've given you is some type of line that is what they call a slant. It's at some type of angle, right? Like these lines. Do you notice how they're slanted, right? The equations I want to talk about, these special cases, are when lines are perfectly vertical versus horizontal. There's a rare formula that we do, and it's very, very straightforward. It's very, very easy. And that's what I want to end with today. All right. Okay, so the first one. Let's talk about a horizontal line. Horizontal lines are lines that are perfectly flat. They have a certain type, a certain style of equation. If I were to draw a horizontal line, let's say I'm drawing a horizontal line right here, flat against me. Notice the line itself. It goes on forever, right? But did it hit the x-axis? No, it didn't at all, right? It only hit the y-axis. So here's the rule. If you look at which axis did I hit, I hit the y-axis only. So that means this horizontal line will only have a y for a variable. It won't have an x like these other ones do. It only has a y because it only hit the y-axis. That's my shortcut that I always give you. What number did I hit on the y-axis? What number is this? What number is that on the y-axis? Say it again. -4, right? That's your equation. That's the equation for a horizontal line. It's the y equals and then whatever number you hit. So if I went up here and I drew another horizontal line right here, what would be the equation for that? Say again? 1. Yep, hit 1. This is the 0, so that's 1. Okay. Makes sense? Like which axis you're hitting? Now the minute it goes slant, you know, we tilt it some way, now it's going to hit both axes, and then that's when it would be one of these other equations. Because it has to have an x and a y, because that's the variables that it's hitting. Right? So horizontal line, you just tell me the number. So y equals whatever number it hit on the y-axis. Okay? All right, now let's do a vertical line. Okay, so a vertical line, something like this. Now, on a vertical line, did I hit the y-axis? No, so it won't have a y for a variable at all. It will only have an x, because that's the letter, that's the variable, or the axis that it hit. What number did I hit on the x-axis?
2.
It's positive 2, right? That's your equation. It's x equals 2. So, how you do horizontal lines and vertical lines, it's whatever axis it hit, and then the number it went through on that axis. That's like the equation. That's how simple it is. Some people, like, they don't understand that. They don't understand, like, why it was that. Because basically it tells you which axis you're hitting. That's why these have 2s in both letters, because it's hitting both axes at some point. Now there's another way to explain it by using like zeros and undefined stuff in there, but I don't want to do that yet. Okay, questions, comments, concerns about horizontal and vertical at the equation format. That's like the easiest way I can teach you. Okay, we're done for the day. Make sure that tomorrow you do have notes. We will have a few notes in the beginning. Talked about, you know, certain problems that we're going to do in the homework. Homework is really easy. It's not like all the stuff we've been doing. It's kind of a mixed bag of different things. So it'll be kind of the stuff we've talked about the last 3 days. So, you know, coming up with equations of lines, graphing sometimes, and then doing some stuff with it we find where things are wrong. Like those things. Okay. Just to let you guys know, today will be one of those rare chances. I want somebody to go on my website maybe tomorrow morning sometime, maybe at home, maybe tonight. I have 2 cameras set up that recorded today's lesson. I want to see which one looks better. So I had the GoPro and I had an actual DSLR for that. I want to see which one looks better. Or what's that? Trying 2 different cameras, see which one this one yields.
Why might be on TV?
It's only going to get to the top of the front.